I'm writing all over it. This first part is just doesn't like my finger. You have to use the pen. Very picky. Is just some definitions. Now, unfortunately, the person who's watching this can't see the greatness that I'm going to show you, but I am going to show you all of the sets of numbers. When you first went to kindergarten, you learned how to count naturally. How do you count naturally? 1, 2, 3, 4. So those are called natural numbers. They're the smallest set that we have, okay? So if we scroll down a little bit in this picture here, I'm going to write natural numbers. I'm just going to write natural because they're all going to be numbers. It's the smallest set. It's included in all the other sets that we have. Because if we add just one more number, because there came a time in life when we were like, wait a minute, I had 10 gummy bears and I ate 10 gummy bears.
Good.
Now what do I have?
0.
Zero. Zero's not in this set. So there came a time when we needed another number. So we have added 0 and called the set the whole numbers. The whole numbers are 0 and all of the natural numbers. Those are part of them. So the whole numbers include 0, 0, and the natural numbers. Those are all part of it. So I'm just going to put a 0 after it because it's only one number that makes a difference between the whole and the natural numbers. So then there came a time when I was looking at my money and I had $10 and my brother borrowed 15. Can he borrow 15 for me? No, I don't have 15. But that's not, that number that we have left isn't in here. What's that number? It's a negative number, isn't it? It's a negative number. So then there came a time when we needed to know the integers, the negative numbers, and they include all those negatives, -1, -2, -3, -4, but they also include 0 and all the positives. So integers include everything you learned since kindergarten plus the negatives. I know, it's amazing, right?
Whoa.
They're all in here. All of the numbers are in this set of integers. Tell me what you know about integers. You know something? What do you know, Eliza? Never mind, Isaac.
Every number besides decimal is fraction.
True. True statement.
You can use it for temperature and
You can use it for temperature because we sometimes here in Canandaigua go below 0. And what's the other thing? Altitude. You can be below sea level. Is that what you're talking about? Yeah, you don't usually want to live below sea level, right? They flood out there.
Yeah.
How about you, Cameron?
You can use them in like math equations and stuff.
You definitely can use them in math equations, yeah. Anyone know any other places you might see negative numbers? Avery.
Like math class.
Say it again?
In math class.
Besides math class. Oh, if you spend too much money, your bank account will be negative. That's never fun. Oh, Vanny doesn't like seeing that. No. Did she steal yours, Luca? Yeah. Did she steal yours, Riley? Yeah. Anyone play a game that might use a little negative numbers? A little golf? Yeah. Is it good to be negative when you're playing golf?
Yeah.
It is. So you want to get to the hole less times than they think you should. Par is 0, but below par, or if you ever watch golf, you'll see that the winners are negative. So negative numbers play a really important role. Now, Isaac mentioned it is everything except for the decimals and the fractions. And we do have a need for decimals and fractions, don't we? Enter, oh, I didn't change to green. Enter the rational numbers. Rational numbers are any numbers that can be written as a fraction. So for example, 5 can be written as 5/1. I really need to get a new rational bag. It's kind of sad. So rationals are all of the decimals and fractions, but they also include all this stuff too. So rationals are a really big set because they include everything we've been talking about. So down here, I need to add integers. And now the rational numbers. So rational numbers include everything in this circle. So a natural number is rational. A negative number is rational. Okay? There are some numbers called irrational numbers. Did you ever meet an irrational person?
Nope.
You have? What were they like?
No clue.
No clue. Because you can't talk to them, can you? Luca, what's an irrational person like?
Like, they will only go with their thing. Like, no, I am right.
They are right.
Oh, yeah,
Let's talk them out of it, right? And they probably go on and on about it, right? And they never stop. They just go on and they never stop. That's what an irrational number is. Numbers, is a fraction, never end and never repeat. That's an irrational number. Pi is an example of an irrational number. I'm missing the middle, and I didn't fix it because we're moving soon, but 3.1415926 something 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 932 goes on forever, and there's no pattern to the numbers. It's called irrational. They are in their own circle. They aren't part of that at all. So integers are not irrational, they're rational.
Where did pi even come from?
What a great question. Where did pi even come from? In fact, it's my favorite math question of all time and brings me to the reason of why I have a hubcap hanging in my room. My most favorite math object. You were wondering? It's the most common question asked in my classroom. Why do you have a hubcap? I usually have more, but they're in the boxes. So pi comes because, Isaac, no matter what size circle you have, if you measure all the way around, anyone know what that's called? The circumference. And you divide it by all the way across, anyone know what that's called? The diameter. You always get 3.1415926. Always, no matter how big or small your circle is. And that's why pi is amazing, because you know those tractor tires when you were little and went to some farm and you could stand on them, they were so big?
Yeah.
If you measure the circumference and you divide it by the diameter, you still get that number. 3.1415926.
Why?
Every single time.
Why?
That's what makes it so interesting.
I was gonna say
Because this distance right here could fit around here 3 full times, plus a little, every single time. And that's what pi is. Thanks for asking, getting me completely off track. When Mrs. Reinke's students play this video, they're going to be like, why are we talking about pi? But pi is irrational. It never ends and it never repeats. This poster keeps going all the way over there.
What's pi used for?
It's used in circles and calculating area of circles and circumference of circles and circular stuff. Everything to do with circles. Okay? Now, all of these numbers, whether they're rational or irrational, are all real. Real numbers. They're all real numbers. Believe it or not, there is a set of numbers totally separate from real numbers that are called imaginary.
What infinite?
No, imaginary. They are the square root of negative numbers. So you say, like, why do we bother to call these real? Because when you get to higher levels of math, maybe high school, definitely college, if you take more math in college, you'll learn about imaginary numbers. They're represented with a little tiny I. Not lying, telling the truth. Okay, so here's a number line that can visually show us what these numbers are. And I'm going to start to put them on your desk. I was going to hang it up, but I'm going to be moving, so I don't know if I'll do that or not. We'll see. So here we have 0. 0, even though it's in the middle, it's still an integer, right? It's a whole number, and whole numbers are part of the integers. All of these numbers are positive to the right. Positive integers go to the right of 0. Let's get out a nice red color. And negative integers go to the left of 0. Makes sense, right? So as we move on the number line, numbers increase as we move right. So as we move to the right towards the hallway, the numbers get bigger and numbers decrease. See this arrow here? Decrease as we move left. Hopefully you've seen a little bit of this before. Is that true? Good. So nothing too earth-shattering here. So I've got an arrow over here showing these are moving right, and an arrow over here showing these are moving left. Any questions before we go to the next page? Okay. Sweetie, it's so early, right? Can't we start school at 9? Starting at
No, not even 9.
Oh, it's
But then it
so
wouldn't end super early.
painfully
If we started at
early.
like 10 or 12.
No. Here's an example that shows the number line going up and down, like Derek mentioned in temperature. Yes, Bella.
I was gonna say that my cousins go to school at 9:30. They live in Florida.
Florida starts at 9:30.
At least
Wow, that's cool. What?
When Europe get like Wednesday off, like they get like 4 days off.
Well, my nieces actually live in Switzerland, which is in Europe, and they actually go to school a lot more than we do. But what they do is they have a 2-hour lunch break. So they actually walk home from school, have lunch at home, and then go back to school. So they're actually there later because in Europe, lunch is a big deal. It's your main meal of the day, and then you have like soup and sandwich for dinner. It's different than
I
how
heard that
America.
like some places they get like Wednesday off.
Maybe, definitely. There's a district in the Rochester area, I can't remember which one, that starts the elementary school starts early like we do.
Is it Webster?
Yeah, I don't know, might be.
I think my cousin does that.
Oh, okay. And then the middle school starts later,
Yeah.
which makes more sense because middle schoolers need more sleep.
Yeah, we do.
Growing. You're growing.
Yeah, I think
Yeah.
Okay, so here's 0 on our thermometer right here. So this number line is going this way. We have Celsius and Fahrenheit. So actually I'm going to erase that because we're used to this being 0. Because we use Fahrenheit here in the States, different from the entire rest of the world, but that's okay. What is the temperature on the mild day? So this stuff right here goes up to some number. What's the temperature on this day?
64.
64 would be one up. I think it's more like 62 or 63. Yeah, 63. 63 degrees above zero. That's how we say it, just like Derek was telling us. And then this day is really cold. This day is negative 20. So it's 20 degrees below zero. So your number line can go up and down, or it can go side to side. Okay? Just so you can see different ways that it might look.
Why did you put 63 below the above?
I don't know. I don't know why.
And then
Should I change it? I don't want you to have to erase it.
Well, no.
63.
And
I
then
don't
change-
know. I don't
and then
know
change
why
the
I do
20 to be
most
below.
things that I do. I have no idea. So here's some other terms that would indicate that you have a positive number above zero. Above sea level. We talked about your bank account. You can gain money or make a profit. That would be positive. You can deposit money into your bank account. Deposit is a positive number. It's going into your account. Here's some terms that would indicate a negative or a below zero. You with me, Elijah? Below sea level. You can lose or have a loss of money. That would be negative. Or this word seems to be new to seventh graders. You can withdraw
I'm
money.
withdrawing you from the school.
That's right. I'm taking you away. That's negative. I have a negative student. Does anyone else hear that really high pitch sound?
Oh, yeah.
I do. Right? So when you withdraw, you're taking money out of your account. So that's making your account
to go on a shopping
less
spree.
negative. Yeah. Elijah, did you have a question? Because you said you weren't quite following me. You want to ask me something? Because it's all about learning, so make sure to ask for sure. For sure, for sure. All righty. So let's write some. Write the value of the integer that represents each situation and plot it. Plot means we're going to put it on the number line. So what integer would I write for an average temperature that is 10 degrees below zero? What would I write, Alex? Negative 10. And I'm just going to plot that on my number line. I'm going to find negative 10 and put a point there. How about if Sarah deposits $20 into her bank? That's a positive 20. You don't have to write the plus sign in front of it. We assume it's positive if there's nothing there. And so we're going to plot that on the number line. Find 20. Well, that high-pitched noise isn't distracting at all, is it? What a lie. All right, here's a little football. If you're not into football, you're trying to move forward towards your goal so you can gain yards. Or if the other team pushes you back, you can lose yards. So if Nick loses 6 yards in football, is he what integer would I write? Negative 6. And I'm going to plot that on my number line. I see negative 5, but I'm not sure if negative 6 is here or here. So I'm going to start at 0 and go negative 1, negative 2, negative 3, negative 4, negative 5. Negative 6 is over here. Remember, it's kind of like it looks opposite. See how these almost look like mirror images of each other? How about if Ben withdraws $40 from his bank account, Kayla? Negative 40. And that one's easy to find. Okay? So hopefully this looks familiar to you. And if you look at the next page, your homework looks like this. And it's just the front of the page. There's It starts notes too. So it's just the front of the page.
Okay, you're so nice.
That's very exciting. You have about 4 minutes to start it. Remember that your name cards need to go back in your binder so I can use them again tomorrow. And, oh, I have to remember to stop my recording. I hope that